Hello, this is Mr. Brooks, and welcome to Lesson 10-4, Perimeter and Areas of Similar Figures. In this lesson, we're going to find the perimeter and area of similar figures. First, let's review similar figures. Similar figures have their corresponding angles congruent and their corresponding sides proportional. The ratio of the lengths of the corresponding sides is the similarity ratio. The ratio of the lengths of the corresponding sides is the similarity ratio. Now that we've reviewed similarity ratio, let's see if we can figure out how that's related to their perimeters and their areas. If the ratio of two figures is A to B, then the ratio of their perimeters is A to B. And the ratio of their areas is going to be A squared to B squared. All right, let's look at some examples, see if we can get this figured out. All right, in example 1, they give us two trapezoids, and their corresponding sides are 6 and 9. So their similarity ratio is going to be 6 to 9, or 2 to 3. That's their similarity ratio. So what's the ratio of their of their perimeters going to be? Their area of their perimeters is also going to be 2 to 3, and the ratio of their areas is going to be A squared to B squared, which in this case would be 4 to 9. Okay, quick check number 1 says two similar polygons have corresponding sides in a ratio of 5 to 7. What's the ratio of their perimeters? And then what's the ratio of their areas? Please pause the video while you try to figure this out. Hopefully you will agree the ratio of their perimeters is also going to be 5 to 7, and the ratio of their areas would be 25 to 49, A squared to B squared. All right, example 2 looks quite a bit tougher. They're telling us two similar pentagons have a ratio of 4 to 10, which hopefully you'll reduce to 2 to 5. So the ratio of their areas is then going to be 4 to 25. All right, and you square both of these. So the ratio of the areas is 4 to 25. If the smaller one has an area of 27.5, what's the area of the big one? You're just going to set up a proportion and then do cross products to solve it. So you're going to get 4x equaling 687.5, and you divide both sides by 4, and x is approximately going to be 172, which would then be choice C. That's approximately 172 when you divide that by 4. Quick check number 2 says the corresponding sides of two similar parallelograms is a ratio of 3 to 4. The area of the larger one is 96. Find the area of the smaller one. Please pause the video while you try to figure this out. If their similarity ratios is 3 to 4, then the ratios of their perimeters would also be 3 to 4, but the ratio of their areas is going to be 9 to 16, A squared to B squared. So we're going to set that equal. This time the larger one is 96, so that goes on the bottom, and we've got to solve this for x. So we're going to do cross products to try to figure this out. So 16x is going to equal 9 times 96, which is 864. Then you divide both sides by 16, and you get the area of the smaller one to be 54 square units. In this case, 54 square inches. Now let's look at example 3. Community service. During the summer, a group of high school students used a plot of city land and harvested 13 bushels of vegetables that they gave to the food pantry. Their project was so successful that the next summer the city let them use a larger, similar plot of land. In the new plot, each dimension is 2.5 times the corresponding dimension of the original plot. How many bushels can they expect to harvest next year? All right, please pause the video while you try to figure this out, and I'll tell you right now, it's not 13 times 2.5. Okay, the ratio of the original plot of land to the new plot of land is 1 to 2.5. So the ratio of their areas is going to be 1 to 6.25. That's the ratio of the areas. You got a square, A and B. So the ratio of 1 to 6.25, 1 over 6.25 is got to equal 13, that's how many bushels the old plot gave, to X. So you're just going to simply do cross products. X is going to equal 13 times 6.25. So you're going to get approximately 81 bushels of vegetables, or just a little over that. All right, quick check number 3 says the similarity ratio of two similar pieces of window glass is 3 to 5. The smaller piece costs $2.50. What's the cost of the larger piece? Please pause the video while you try to figure this out. And remember, when you're buying glass, you're going to buy it by the area. By area, I mean in square inches or square feet, square centimeters, etc. Well, since their similarity ratios is 3 to 5, the ratios of their area are going to be 9 to 25, a squared over b squared. And the cost of the smaller one is $2.50. We've got to get the cost of the larger one, which is x. So we're just going to do cross products. So 9x is going to equal 62.5. And when you divide both sides by 9, you get the cost of the bigger one to be approximately $6.94. Example 4 says we're going to find the similarity and perimeter ratios when they give us the area of two figures. The area of two similar triangles are 50 and 98. What's their similarity ratio? What's the ratio of their perimeters? Well, hopefully, before you even start, you realize those are going to be the same. Their similarity ratios is going to be the same as their ratios of their perimeters. Well, since their ratio of their areas is 50 over 98 to get their similarity ratios, or the ratios of their perimeters, we're going to have to take the square root of both the top and the bottom. So this is the same as square root of 25 times the square root of 2. This is the same as square root of 49 times the square root of 2. So you get 5 times the square root of 2 over 7 times the square root of 2. Our square roots of 2 cancel, and we're just left with the similarity ratio of 5 to 7. And same with the ratio of their perimeters, 5 to 7. In quick check number 4, they give you the area of two similar rectangles and ask you to find the ratio of their perimeters, which is the same as their similarity ratio. Please pause the video while you try to figure this out. Okay, the ratio of their areas is going to be 1875 over 135. Now how are we going to get the ratio of their perimeters? We need to take the square root of both the top and the bottom. And this is a massive problem in simplifying radicals. Hopefully you see that 25 will go in there 75 times. And in this one, 9 goes in there 15 times. Those are the perfect squares that go into both those. So what do you get? Square root of 25 times the square root of 75 equals square root of 9 times the square root of 15, which equals 5 times the square root of 75 over 3 times the square root of 15. Now let's try to simplify the top a little more. It's going to be the same as 5 times the square root of 25 times 3 over 3 times the square root of 15, which gives us 5 times the square root of 25 times the square root of 3 over 3 times the square root of 15, which gives us 5 times 5 times the square root of 3 all over 3 times the square root of 15. So that is 25 times the square root of 3 all over 3 times the square root of 15. Now we've got to multiply the top and the bottom by the square root of 15 over the square root of 15. On top we get 25 times the square root of 45. On the bottom, we're going to get 3 times 15. Square root of 15 times square root of 15 is 15. Now I'm going to need to continue this on to the next slide. This is what I had from the previous slide. We're going to have 25 times the square root of 45 over 45. All right, 5 will go into both of these. 5 goes in there 5 times over 9 times the square root of 45. Any perfect squares that go into 45? Yes, 9 goes in there 5 times over 9, which is 5 times the square root of 9 times the square root of 5 over 9. And the square root of 9 is 3, so you get 5 times 3 times the square root of 5 over 9. 3 goes in there once, 3 goes in there 3 times, and we finally have our answer. 5 times the square root of 5 all over 3. That's the ratio of the parameters. 5 times the square root of 5 to 3. This concludes lesson 10.4.